Hi folks, I'm Jason Radford, the CEO of Volunteer Science. Today I'm going to talk about what interactive web apps are and when you're building them for research purposes, what is it that you're actually doing? Like, why are they different from just a normal website or a web game? What is it that makes them a web app, and what are you trying to really do here that's different and hard? Once the idea is like once you understand what a web app is, you'll be able to understand what you need to do to build one. So first of all, I'll talk about what web apps actually are and how they're different from web pages and games. How you actually go about building them. How do you host and test them? So like you got to build it and then you got to put it up somewhere so that people can take it or use it. And then a couple of other things around like things you should just know for building web apps and where to go get help. Okay, so an example of what are the examples of interactive web apps? So if you have an app on your phone that tracks your health, where you're like logging in your calories for the day or what you ate, or if you have a to-do list where you're putting in like your to-do list for the day and checking them off. I put in Jira, HipChat, and MailChimp. Like these are very all common, well-known examples of web apps. Not web pages, not games, web apps. And the reason they're not web pages, if we think about web pages, we think about blogs or news sites, organizational pages like northeastern.edu. What's different about these web apps versus these web pages is that they're dynamic and personalized. So as I enter in my to-do list, I'm able to see that to-do list get updated. As I check something off, that data gets updated, and that updates my interface. And I'm able to see like what did I do, what do I have left. I can add more to it. And so there's this interactive, personalized aspect to interactive web apps where, as a scientist doing research, what we want to do is have people put in data and then update the interface with whatever we do with that data. Whether it's just showing people the next page or changing the interface so that it behaves differently. All of that stuff is sort of within the world of the interactive web app. So we're building an app that takes data in and then changes the interface based on whatever they put in. Which kind of sounds like a web game, like Angry Birds or Pac-Man or Fortnite, where we're like pressing buttons and moving characters, and as we're entering data, like these things are moving. What's different about web apps versus online games is that with the online games, what you're doing is you're just sort of like building out a world and setting out its rules, and then people sort of play in that world. The gameplay is open-ended, like not like in the Grand Theft Auto kind of open-ended world kind of thing. But literally, like people can move left, they can move right, they can move up, down. If they hit I'm thinking about Pac-Man right now. If they hit a little ghost, they're going to die. But if they don't hit the ghost, they don't die. Whereas the interactive web app is something where we're getting people to do very specific things, and we have a very constrained set of data that people can put in, and very constrained set of things that happen on the way out. And there's not a lot of latitude for people. Now you can create a lot of latitude if you want, but the idea is that it's not that we're not sort of coding a world where we create things that have rules attached to them, which is what games are. Instead, we're creating mostly static interfaces that have some degree of updating on top of them. So the way that I like to define a web app is that it's an online interface for putting in data and displaying different responses based on the data being put in. So how do you build a web app? So the philosophy that I have here is that it's called a ClickHar. You want to design the content, the actions, and the response. So the content is the interface that you want to build, like the web form, the like point-and-click system, or the images that you want to show. You have the content laid out. Like you want to know what's going to go where and what thing is going to fill in these different buckets. The next thing you want to do is connect actions to it. So like if you want people to fill out a survey, you have them like click buttons, that's the content, and the action is when they click a button, that data gets saved somewhere and they move on to the next piece. So you want to have people be able to push that button to like initiate an action. It could also be like clicking on a particular image saves that image as the person's selection. So that's an action of clicking on the image. And the response is how you update the content in response to the actions. So if the action is clicking a button, the response is saving the data, showing the next thing, or highlighting the image as the selected thing and saving that as the selection. So you want the content that people are looking at, the actions that they can do with that content, and then the rules around responsiveness, about what happens when those actions get called. So an example here is like you're building a personal calendar, and the content is your day, your month, or your year view. So like if you were looking at your calendar, you can see your week, you can see the month, I don't think you can see your year, probably not much. But there's like very standard interfaces for these things, and you can put in whatever you want, but they're always going to show up in that same kind of week or day interface. The actions that you can do, or you can change the view, so you can go from week to day or day to month, and you can add in new events. So your action would be to open up the add a new event form, and then type of stuff in, and then you click the button to save, and that data gets saved. And then when you go back to the weekly view, that data gets rendered in a new way, and that's the response. Is that rendering the data in a new way? So you're actually able to see the events that happen that week or today or next month. So that's the way to think about the app that you're building, right? The content, the actions they do on that content, and then the response that's going to happen. Again, so why is this not like a normal website? Because what's happening is you're not creating a new web page for every calendar event or every view. You have a very set number of web pages. So, I've only talked about 4 screens, and all of this activity for the personal calendar. There's the day view, the month view, the week view, and then the add or delete calendar events view. And that's it. There are 4 pages to this whole app. But we're doing tons of stuff with those 4 pages. Okay, so the basic ingredients for any web app. So technically you can do this in a bunch of different languages, but for the most part, this is all HTML, which is, what content goes where. This is like the Microsoft Word of the web. It's like, this is what the actual words are going to be. This is what the actual images are going to be. CSS is the sort of markup for this. It tells us how it should look. Is it going to be big? Is it going to be small? Is it going to be green? Is it going to be blue? Is this thing going to be shaded or bolded or centered? The CSS, called Cascading Style Sheets, determines sort of the look of the content. The last piece is the real engine here is JavaScript. And JavaScript is what's going to tell us what actions are there, and then what happens when those actions get shown, or what happens when those actions happen. So JavaScript, for those who have some familiarity with programming, is an object-oriented programming language. So you create objects and then you do operations on them, and that's all the JavaScript is. What makes JavaScript really useful and why it works in the web is that there's a library for taking HTML and CSS documents and changing them dynamically. So like being able to show or hide different HTML blocks, changing the CSS live in the browser without having to download any new code or any new pages. That's the power of JavaScript. It's like grabbing that stuff and changing it. The other thing is that JavaScript is also really good for storing and manipulating data. So as people put in their name and their age and their sex and their job, all this stuff can get stored as a JavaScript object, and then you take that JavaScript object and you put it in your server, or you print it out as a text document, whatever you want to do with it. But whenever people put stuff into your web app, that's going to get saved as a JavaScript object. So, content, action, response. Your content is all HTML and CSS. HTML and CSS will tell you what goes where and how things are going to look. And then JavaScript is going to determine what actions are possible, what actions you will actually be able to, your web app will actually be able to respond to. And then the actual response will be sort of this coordination of JavaScript, CSS, and HTML, where if you put in your name and you click enter, JavaScript is going to say, update this page, and then this CSS, it's going to change the CSS and HTML so that the CSS and HTML now puts your name in bold in the center on the top of your page. This is, hi, Jason. So all 3 of those go to making that response happen. So when you're developing web apps, what you want to do is you want to create your separate files, your HTML file, your CSS, and your JS files on your computer, and then open them in your browser. Okay, sorry. There are a couple ways of doing this. One, you can do it locally. So you create these files in your computer, and you can open them in the browser. Just open up Firefox and click on the HTML file. Ta-da! The next thing that you can do is use a prototyping service like JS Fiddle or JS Bin, playcode.io. All of these do basically the same thing that you're doing on your local machine, but you're doing virtually. The pros here, the reason why you would do it is that it's easy to use and test. If you're not super savvy around like how you're supposed to structure your files in your local computer, going to a JS Fiddle or a JS Bin and just using that is much easier. And they're also it's easy to use sort of common packages like Bootstrap and jQuery rather than having to download all that stuff locally. The cons is that it's not actually for actual use, so you can like use JS Fiddle to figure out how to center something or make an interface look right or get the right function written, but you can't actually like save data there. You don't want to actually have people see your app unless you don't want to actually have people like using your app through JS Fiddle. You would want people to use the app on an application service like a Volunteer Science or in your own server, which I'll get to in a second. But this is sort of where Volunteer Science fits into like developing your web apps world. Now, the pros here are that you don't have to worry about uptime or backend data storage, and we have custom APIs. That means like you don't have to host your own stuff. You don't have to worry about the backend. You don't have to worry about figuring out how your server is configured or making sure that your server is still up or that your server can hold 100 people. Like we handle all that stuff for you. And then we provide some custom APIs, so you don't have to write all of your code from scratch. You can just call one or two function calls from Volunteer Science, and the stuff that we've pre-built will just come right in. The cons are, of course, that you have actually little control over the backend, particularly around data storage. We give you, read-write access to the backend, so you can store data as you want it. But that doesn't mean that you can, store whatever you want. You can store like the URL for an image, but you can't actually store the image itself on our service at the moment, for example. The next step up is having your own server. So you create a server on Heroku or Amazon Web Services, and you just upload your code there. You get your own URL. You have like research, myresearcher.com, jasonradford.com, and that gives you full control over the environment. You can create whatever you want in R Shiny or something in Python or something again in JavaScript. Do whatever you want. The challenge is, of course, then you have to host your own server and have to figure out what happens. You're completely responsible for the stack that you're coding on, which again is getting easier and easier these days. But it's still you have to be prepared to be a full stack developer essentially to get this stuff working. So develop how you feel comfortable. The things that you should know. A couple of just basic things that come up all the time that you just should know. So jQuery is a JavaScript library that makes JavaScript a lot easier. So a lot of what we do on Volunteer Science is actually written in jQuery, not JavaScript. I mean, it's sort of JavaScript, but it's specifically is jQuery. So get familiar with jQuery, use it. It's so much more efficient and easier to read than JavaScript. The next thing is Bootstrap. So Bootstrap is one of the greatest inventions in web development history, because what it does is it allows any web interface to be mobile friendly. So if you build it correctly, you can always screw it up and like make it look ugly. But the reason Bootstrap exists is so that you can build these HTML and CSS objects that actually get bigger or smaller or change their orientation based on the size of the screen. So you can build a website that actually works on a laptop or on a computer monitor or on a tiny mobile phone because the interface is responsive. And so technically speaking, Bootstrap is just a library of pre-built like HTML, CSS, and JavaScript that all you have to do is like use the right kind of HTML object with the right CSS, and it'll give you a responsive interface. So I don't know if I have it here, but when you're deciding to build a study, like you want to build a study for a mobile device because it's easy because you can go from mobile to desktop, but you can't go from desktop to mobile. Typing in, pointing and clicking, like you want to be able to build an interface that works on mobile first. But the good thing is that you don't have to build a mobile app to get a study working on mobile devices. You can just build it in Bootstrap. Which again, Bootstrap is just HTML, CSS, and JavaScript. You just use Bootstrap to build a mobile-friendly interface. The React.js is actually a library of pre-built JavaScript functions that actually can give you a mobile app or web application that works more natively with mobile than Bootstrap does. It's sort of like volunteer science in that it offers a lot of easy to use functions, so that you don't have to do all of this yourself. And that's what a React.js is. Lastly, for those of you who are again not so familiar with how data gets stored, there's MySQL, which is a programming language for actually storing data in a database and getting it back out. There are things like NoSQL and Postgres. I'm sort of waving my hand as people who know what MySQL is, or who are doing web app development want to know how is my data being saved, and in most cases it's using MySQL. In volunteer science, you'll never see the SQL. You'll never even see the Python on which we're using SQL, but just know that's on the back end what's going on. And lastly, if you need any help, there are two big things that you should do. Well, three. Number one, watch all these online videos about how to do this stuff. If you're starting from scratch and you just want to have a crash course on what is HTML, CSS, and JavaScript, there are a ton of online classes. Take those to get that high-level, big-picture overview of what are the things that I can do. Once you have a basic grasp of just what it is that you're doing, you can go to w3.org, and that'll give you basic documentation for all of the functions, the classes, the arguments that are used in these common web languages like HTML. They include PHP for those that are still using PHP. And so if you want to know how do I do a table or how do I embed an image, go to w3.org and they'll teach you all the basics for just how to do something. Now, if you have a very specific problem, how do I center an image, or my image is too big, how do I make it smaller? Stack Overflow is exactly where you go. If you have a very specific problem with a very specific thing, more likely than not, 100 people have had that same problem, and they've all asked it on Stack Overflow, and there's just a standard answer. More likely than not, too, if you do a Google search for a very particular, narrow question about how something works or something broken, you'll see a lot of Stack Overflow responses to that question. Just click that, and more likely than not, that will be your answer. So I think that's it. Yes. All right. So if there are any questions, I'll take the questions. Otherwise, thank you.